Hello everybody. In video 3 we have the first time programmed our model onto the hardware and ran it, and in this video I want to show you now the online debugging capabilities using the scope and modifying the parameters in the model. So first of all, we have to make sure that we have the right connection settings, depend on the framework project. And typically it's 115,200 baud, and I know that my board is connected to COM21. So we can leave the setup tab, and with the very first icon here, connect to target, we can enable the UART communication with the target. It takes a little while, and once the two connectors go together, we are physically connected to the hardware. There is some handshake ongoing, so we really know that there is a physical connection available. So the next step is that we have to transform the model to the communicator. Once this is done, the scope icon gets enabled, and by clicking on it, the scope window opens. So now I'll bring both windows to the same screen. So the first and most important button is the sample button. So with this, we start the sampling, and if we click on it, we see signals coming in from the target. So I can stop here, I can make a single shot, shows only one screenshot, and then it stops. And at the moment, if the sample time factor is set to 1, then every execution cycle, the values are measured and displayed then on the screen. In case we want to see a longer period, so here you see we have a sampling time of 100 microseconds. So with the array size we have defined in the framework project, we see a total of 50 milliseconds. If we want to see 500 milliseconds, then we just take every 10th sample, and once we press sample, then the sample time is calculated to 500 milliseconds. So in total, we see now 500 milliseconds. And you see that we have more periods. So if we stop the sampling, then we now can zoom in by just dragging a square to the area we want to see. And for instance, this here is an analog signal coming in, and we can zoom into the details. If we want to go back to full scale, then we just click and drag to the left, and everything goes back. If we right click in the scope, then we have the properties windows where you can make all the required changes. You can save or copy the screenshot. You can also zoom in and out through the menu here, or you can also switch back to auto ranging. So plenty of nice options. The scope also allows you to save the data with data export in MATLAB or Scilab format, and in one of the later videos I will also show you how to use the data then back in Scilab. On the channel configuration, we can select up to 8 different signals. So enable means data is captured, visible means that the data is also shown. So in case I don't want to see the blue line, I just switch this to unvisible, and I get the green signal here. If I also want to get rid of the red one, you can also select the color if you want to up to 8 of the colors here. And then you can select which signal you want to see. So you can select between IO port, block port, or address. So most important are the block ports and the IO ports. For an IO port, then you can select in port or out port. and then you can select which port you want to see. Additionally, you can also set the gain and the offset. If you have signals that overlay, you can shift them up and down, like on a real digital scope. Let's also look a little bit more on the block port. If you select block port here, then you have the possibility to select between all the available blocks in the model. And on every block, you can select any input or output you want to see. All the changes can be handled during runtime. So let's get rid of the red signal and let's go back to our filter signals and go back to a sample time factor of 2. Now, if we start sampling, we see that signals are free running, but I would like to have a steady signal. So that's why I enable the triggering. And as we cannot see the green very good at this point, we switch this to red color. So if I want to enable the triggering, I first stop here. I go to normal trigger and I select the input signal of the adaptive PT1 as a trigger signal. So, okay, that's already pre-selected here. So I select the block port, I select the adaptive PT1 and the input signal. And I want to have a rising edge with the level of 0 and a delay of 20% so that we also see a little bit up front of the triggering. So if we press sample now, then we see we have the trigger point here. So these are the 20%. And we have a trigger level of a rising edge of 0. So we have a nice and steady picture here. With this, we can now play with the model parameters and with the settings we have here. The best is if we change the cutoff frequency. So if I double click on the cutoff frequency gain constant block, I get into the configuration window and I can change the value. And for demonstration, I just remove a 0 here. So my cutoff frequency is multiplied by a factor of 10. So I expect that the red signal looks much closer to the blue one as soon as I press enter. So as soon as I press enter, the data from the block here is taken and transferred to the UART onto the hardware. And immediately the effects are seen on the screen here. So if you right click in here, you can set the configuration of the changing values. So you can select a different number of digits. So in that case, probably a smaller value. Then you can select a lower limit and the upper limit. So the lower limit is 0. The upper limit, let's say, is 0.9. And then you can select the increase or decrease. So add step per step or multiply the value with. So step by step. And we want to change with the step of 0.5. And we have a base value of, what do we take? 0.3. Okay. So this means if I use the arrow buttons here, then it goes 0.05 up and down. And you immediately see the changes. The changes are pretty small here. Another feature that also works very well, if you are with the cursor in the constant field here, you go with the mouse over and you spin the mouse wheel and the values are changing. And now you will see that usually the values would go below 0, but in our case, they stay here at 0.05 and they won't go up to higher than 0.9 because we set the limit under the configure window in here. So I want to configure this back for the next time. So just remove all that stuff. And also this one here. Okay. The one cannot be empty, so we have to set it to 0.001. Okay. Yeah, changing parameters works with many other places as well. So we can also change thresholds in the auto switches for up and down. And again, as soon as we press enter, the values change. And we can also configure, similar as before, in which way the values are allowed to change. So another example here, for instance, would be to change the amplitude of this sine signal. So let's configure this channel here for the sine gen 1 output and show the signal here. So we have a sine signal with a lower frequency and an amplitude of 1. Again, if I change the amplitude here from 1 to 0.3, then the amplitude goes down to 0.3. So plenty of capabilities with the scope. Also here, I will show you how to add an offset. So if I add an offset of 5, then we see the value goes up by a number of 5. Okay, thank you very much. Some exciting stuff is coming for the next video.